All right, the next test, or not test, but a type of series that we're going to take a look at, a classification of series, is the p-series. A p-series is a series of the form 1 over n to the p. Much like how we learned about p integrals 1 over x to the p. In fact, the proof of the convergence of p-series for p greater than 1 is attributed to the integral test. This is exactly how we prove that that p-series for p greater than 1 converge. We won't go through the proof here, but it is just a very straightforward application of the integral test. We will instead focus on some examples. So example 3, determine if the following series converges or diverges. So first thing we're going to want to do here is write this as a, write it in the form of p-series. So I will go ahead and write this as 1 over n to the 1.4 plus 3 over n to the 1.2. Now what's really important here is this linearity of series, and we know that if we have two convergent series, we are allowed to add them together and obtain a new series that is also convergent. Similarly, if we have a convergent series, we can multiply by some constant to obtain a new series that also converges. So what I'm going to do is ask or determine if the following two series converge in and of themselves. So the question is, do this series from 1 to infinity of 1 over n to the 1.4 and the series from n equals 1 to infinity of 1 over n to the 1.2 converge? Yes, they do. They're both p-series with 1.4 greater than 1 and 1.2 greater than 1. So, because each of these series converge, I know that if I multiply one of them by a constant, such as 3, if I multiply this series by 3, then we will obtain a new series that converges. Then that new series that converges added to this series will also give us a series that converges, which is exactly this series. So this series does converge since these two series converge. These two series. So to write this out a little bit more formally, I'd say since each of these series converge, we know that the series of 3 over n to the 1.2 from n equals 1 to infinity converges. And therefore, the series that we have, n equals 1 to infinity, of 1 over n to the 1.4 plus 3 over n to the 1.2 converges. Okay. Take a look at example 4. Determine if the following series converges or diverges. So here we're not given an actual compact formula written in summation notation for this series. We're just presented the series written out with the terms written out individually. So what we want to do here is examine what's going on. We've got 8, 27, 64, 125. All of these numbers are cubes. So this is the same thing as 1 plus 1 over 2 cubed plus 1 over 3 cubed plus 1 over 4 cubed and 1 over 5 cubed. And of course, we can always write the number 1 as 1 over 1 cubed if we want to, which is what we'll do so that the pattern, matches up nicely. So this right here is a p-series 1 over n cubed from n equals 1 to infinity. So, does this series converge? Yes. So this converges. Why? It is a p-series. P is equal to 3, which is greater than 1. We don't need a whole ton of justification here. That is good enough. It's a p-series with p equal to 3, which is strictly greater than 1.